LB 3.0 Simulink 2015, designed by Seaside Engineering's Chief Programmer, Jada Sumter. Here at Seaside Engineering, we keep things simple and effective. Ladybug, or LB for short, is the code name for our Simulink model. It was designed to resemble our robot, Prospector. All the simulations in LB are positioned roughly to where they would be seen from a bird's eye view of Prospector. For example, the platform used to pick up the chalcopyrite is located on the left side of the program, or the front of Prospector, between the wheels. The platform is operated by two buttons placed on the front of the VEX Cortex controller. The simulation uses a constant of 1, a gamepad button, a DC motor, a display, and a scope. In the program, the constant of 1 represents when the controller button is being pressed. This causes the motor, or in the simulation, the DC motor, to turn. The DC motor block then connects to a display block and a scope. The display shows the speed that the motor is being turned. The scope shows a graph of the simulation. Please note that the scope block shows a graph with a continuous horizontal line when opened. This is because the button is digital, not analog, so the motor is either on when the button is pressed or off. The simulation only simulates the button as if it were pressed. The scoop simulation is similar to the platform simulation, as it also contains a constant of 1, a gamepad button, a DC motor, a display block, and a scope block. The platform and scoop are both operated by a small motor and pulley on our robot, Prospector. They are also operated using the 4 buttons found on the front of a VEX Cortex controller. Each wheel simulation consists of a constant of -1 or +1, a variable, a gamepad, a joystick, a DC motor, a display, and a field simulator block. Unlike the scoop and platform simulations, the wheel simulations are analog. This is why they require a variable block representing the position of the joystick on the controller. The wheel simulation also contains a field simulator. By changing the variable's value, you can control where the dot representing our robot travels on the map. Past versions of LB. Version 1.0, a small circuit that contained basic Simulink blocks. Problems: the Simulink program didn't have blocks required to simulate the robot. Version 2.0, a basic Simulink program using blocks made for VEX. Problems: the DC motor blocks had the same parameters. Bug fixes: the VEX Cortex microcontroller support was downloaded. A special thanks to Simulink and bensound.com.